Good morning everyone, and it's time for our next maths lesson. Now today we are looking at how to convert decimals to fractions, okay? So please will you pause the video once again and copy down the short date and the learning objective. Right, you should have copied down both the short date and learning objective now into your maths books, okay? So let's start looking at our lesson. Now, as we do in school, we are going to start with a review session, okay, a review question. So the first question says, 10 children make 12 meters of paper chains. They each contribute an equal amount to the chain. What length has each child contributed? Now, a little tip with this question, think about, we know how much 10 children have made altogether. They have made 12 meters of paper for all 10 children. So how can we calculate how much one child will have made? The second question says, there are 20 children in the class altogether. What length of paper would each child need to make if they each made an equal share of the 12 meters? Now with this one, you could work it out in a very similar way to you did with number one. But we could also think, if we already know how much 10 children have given, how can we easily work out how much 20 children would need? Okay, so I want you to pause the video here and have a go at those two questions, please. Okay, so you should have had a go at both of those questions. So let's have a look at them now, how we would have worked out the answer. So for number one, it tells us that 10 children made 12 meters of paper chain. So 10 children made 12 meters, and it's asking us what length would each child have made, or what length, in other words, would one child have made if they all contributed the same amount. Now that is very similar to sharing, isn't it? If we had 10 sweets and we all had the same amount, they would be shared out between us. So if we have 12 meters of paper between 10 children, this 12 meters is being shared between the 10 children because they each contribute an equal amount to the chain. So to work out this answer, we have our 10 children as 12 meters, and to work out what one child would have contributed, we would then do our 12 meters divided by, which is very similar to the shared, isn't it, by the 10 children, to get that each child then would have made 1.2 meters of chain. If we wanted to check that, we could then do 1.2 times by 10 and see if we got to 12, and we know if we did that, we would move our decimal place one place forward and we would get to 12 meters, therefore knowing our answer is correct. Number two says there are 20 children in the class altogether. What length of paper would each child need to make if they each made an equal share of the 12 meters? Now this links to what we looked at in the last lesson on Friday, where we found that if we were looking at a multiple of 10, we could partition the 20 into 10 and 2, and we could do 12 divided by 10 and then divide the answer by 2. Now here, we've already worked out what 12 divided by 10 is. It is 1.2 meters. So now all that's left for us to do is to now divide it by the 2, and 1.2 divided by 2 is equal to 0.6. So our answer should have been 1.2 meters and 0.6 meters. Okay, let's start with today's lesson now then. So we're looking at how we can go from decimals to fractions in today's session. Now, the table on the side here shows some learn by heart facts that we should really know. Okay, the 1/6 is a little bit tricky. Okay, but I'll put it in there because it's a useful one to learn. But every other one in this box, in this table, we should know off by heart. For example, we should know that 1/2 is equal to 0.5. We should know that 1/4 is equal to 0.25. And we should know that 1/8 is equal to 0.125. We should also know that 1/3 is equal to 0.33. Really, we know that is 0.333333 or 0.3 recurring, which means it just carries on going, but we can write it as 0.33 or 0.333. Now, what we're going to first do, this because it's the first technique to go from a decimal to a fraction, is we can use our learn by heart facts here, which are represented in this table once again, and we can see, is there a link between any of our decimals here and our first decimal that we need to convert, 0.66. So I can have a look down here and I can see, can I go from 0.2, is there anything I can do to 0.2 to get to 0.66? There's no definite link there. What about 0.1? No, I could get 0.2, 0.3, 0.4, 0.5, but I cannot get to 0.66. However, if I look carefully here, I can see that 0.33, there is a clear link to 0.66, because I can see that 0.66 is just 0.33 multiplied by 2. And I can see that 0.66 is exactly the same as, or is equal to, 0.33 multiplied by 2. Now this table here, and if we know this off by a heart, what we also know is 0.33 is the same as 1/3. So if 0.66 is the same as 0.33 times 2, it is also the same as 1/3 times 2. And we have already done this year in school, multiplying a proper fraction by a whole number. And we know if we're doing this, we do not multiply the denominator. The denominator, in fact, just stays the same. And we do multiply the numerator. So we now know that 0.66 is exactly the same as 2/3, because we can link our decimal and fraction learned by heart knowledge to these questions. Let's look at 0.75 then. 0.75, is there a link to the number 1? No, there's not really. Is there a link to the number 0.5? We could if we really manipulated 0.5, but there's an easy way of doing it here. 0.33, can we get 0.75? Not really. 0.25 to 0.75. Now, we should be able to see as well here that the number 25, we know we can easily get to 75, because we can all count in our 25s. 25, 50, 75, 100, 125, 150. So we know then, because there's a link between 25 and 75, there has to be a link between 0.25 and 0.75. So 25 multiplied by what would give us 75? Well, we know that. 25, 50, 75. So that is 25 times by 3. Would give us 75, so 0.25 times by 3 must give us 0.75. But we also know, because of our learn by hearts, that 0.25 is exactly the same as 1/4. So if 0.75 is the same as 0.25 multiplied by 3, we can now substitute in 1/4 instead of the 0.25, so we also know that 0.75 is the same as 1/4 multiplied by 3. And once again, we have done proper fractions multiplied by whole numbers before. The denominator remains the same, and the numerator we multiply by the whole number. 3 times 1 is 3. Let's look at one more example together, 0.3. So can anyone see here a decimal that we could link to 0.3. We can't link 0.2, because then we'd have 0.2, 0.4, 0.6, 0.8. There is no 0.3 in that link there. However, we can, and you should be able to see, that we can link 0.1 and we can get to 0.3 very, very easily. So 0.1 times by or multiplied by 3 is exactly the same as 0.3. 0.1 times 3 equals 0.3. We also know, because of our learn by heart facts, that 1/10 is the same as 0.1. So I can also now write, instead of 0.1, I can substitute in 1/10. I can multiply that by 3. And again, this goes back to how we know to multiply a whole number by a proper fraction. The denominator stays the same, and the numerator is times by the whole number. So I can now see that 0.3 is equal to 3/10. What I would like you to now have a go at, please, is can you find a link to 0.8? So I'll just clear this board very quickly. Can I find a link to 0.8, and can I therefore convert 0.8 into a fraction? Can I see a link, and this is a bit of a tricky one, to 0.375? And can I find a link in this table to 0.7? And if I can I then convert it to a fraction? Okay, so I want you to pause the video now and have a go, please, at those 3 decimals to fractions. So please pause the video now. Okay, so you should now have had a go at those 3 questions. So let's have a look. We've done those 3 already together. Let's have a look at how we get the answers here then. So we should see that 0.8, there is a link to 0.2. However, there is also a link to 0.1. and you could have used either of these. Now if we stuck with 0.2, we know 0.2 times by 4 is 0.8, so therefore 1/5, because that is the equal to 0.2, 1/5 times by 4 is 4/5. If we spotted the link between the tenths, we can still be correct here, but this time we would have to times by 8 to get to 0.8. 0.1 multiplied by 8 is 0.8. We know that 1/10 is the equivalent to 0.1, so we would then have to multiply 1/10 by 8, and 1/10 times by 8 is 8/10. Now the reason why both of these are correct, and something that we're going to look at a little bit later on today, is because if we think back to how we simplify, if we had 8/10 and we were simplifying that, we would look at, do both the numerator and denominator go into the 10 times table? No, they don't. The 10 does, but the 8 is not in the 10 times table. Do they both go into the 5 times table? No, they don't. Again, 10 does, but 8 is not in the 5 times table. Do they go into the 2 times table? Yes, they do. And whatever we do to the bottom, we do to the top. And we can see that 4/5, therefore, is exactly the same as 8/10. So both of these answers would be correct. 0.375 is the more tricky one here, but there is a link there to 0.125, because 0.125 multiplied by 3 gives us 0.375. And therefore, 1/8 times by 3 gives us 3/8 as our answer. And the final one, 0.7, we should have seen a link to 0.1, and therefore 0.1 multiplied by 7 would give us 0.7, and we know 0.1 is the equivalent to 1/10, and 1/10 times by 7 would give us the 7/10. So they should have been your answers to those questions. What if we can't spot a link though? Because it's all good us saying, yeah, well, you just look for a link between learn by heart facts and then you'll get your answer. But what if we can't? What if we've got a number and there might be a link there, but we might not be able to see it? So let's see how we would do that. And it becomes very simple if we just use a place value chart to help us. And I'm going to show you how we do that now. So if we look at the first number here, the first decimal number, 0.35, and I want to put that into my place value grid here, on my place value chart, I can see that my decimal point is here, and we know that because it is always in between the ones and the tenths, because we know anything ones or higher is above 1 whole, and we know anything tenths or smaller is below 1 whole. Now if I want to put my 0.35 into my place value chart, it's quite easy for me to do. But this is where it becomes really easy as well, because this now tells me I have 0 holes, but I have 35 hundredths. So I can write 0 holes and 35 hundredths. Now, if ever I've got 0 holes, I never really have to write it down, do I? So I could actually just write the fraction 35 hundredths as my answer. And we will look at how we simplify that in a short while. If I use again my place value chart for 0.9 this time, again, remember my decimal point, I can see it there, but if I'm unsure, it is always between the ones and the tenths. Again, I make sure I line it up properly so I can see the 0 is before my decimal point and the 9 is just after my decimal point. And this time I can once again see I have 0 holes, but this time I have 9 tenths. So I can write 9 tenths. Once again, if we've got a 0 as our whole number, we do not need to write that down, and we can just leave our answer as 9 tenths. Let's look at the very last one now then. Again, we're going to use exactly the same method. We're going to put 0.412 into our place value grid. What have I forgotten here? I've forgotten my decimal point. Always make sure you put that in there, absolutely crucial. Again, I have 0 holes because I've got 0 ones and I've got nothing in the tens or hundreds columns. But this time I've got 412 thousandths. So I've got 412 thousandths. And again, we know that if we are writing a whole number as 0, we do not need that to write that down. So instead, we could just leave our answer as 412 thousandths. Okay, so it's a really simple method. If you are struggling to remember your place value decimal and fraction conversions, then use this method instead. Write down your place value columns, line your numbers up, or your digits up properly in each number, and then have a look. We've got here 412 thousandths, we've got 9 tenths, we've got 35 hundredths. Okay. Let's just have a look a little bit more at this then. So can we simplify any of our fractions? Now, we've done simplifying fractions this year as well, and we always ask ourselves 4 questions when we are simplifying fractions. The first question, do both the numerator and denominator go into the 10 times table? Then, do both the numerator and denominator go into the 5 times table? The third question, do both the numerator and denominator go into the 2 times table? And the last question, do they go into any other times table? So let's have a look if we can simplify our fractions, which we got as our answers on the last page, here at all. So we now have 35 out of 100, or 35 hundredths. The first question we ask is, do they both, the numerator and denominator, go into the 10 times table? So is 100 in the 10 times table? Yes, it is. But is 35? No, it is not. So we cannot simplify by 10. Do they both go into the 5 times table? The 35 does, and we know the 100 does. So therefore we can divide both the numerator and the denominator by 5. 35 divided by 5 is 7, and 100 divided by 5 is 20. Remember, whatever we do to the bottom, we do to the top. We then go through our questions again. Do both the numerator and denominator go into the 10 times table? No, they don't. Do they both go into the 5 times table? No, they don't. Do they both go into the 2 times table? No, they don't. Do they go into any other times table? No, they don't. So therefore we have our final answer. If you had left your answer as 35 out of 100, you would still get it correct, but I just want to make sure we're remembering that we can simplify fractions as well. Here, 0.9 equals, we know it equals 9 tenths now, because we worked that out in the last page. We go through again. Does both the numerator and denominator go into the 10 times table? No, they don't. Do they both go into the 5 times table? No, they don't. Do they both go into the 2 times table? No, they don't. Do they go into any other times table? No, they do not. So we cannot simplify 9 tenths any further than that. And if we look at the third fraction that we had 412 thousandths. And again now, we look through our 4 questions to help us out. Do they both go into the 10 times table? No, they don't. We know that because both numbers do not end with a 0. Do they both go into the 5 times table? No, they don't. We know that because both digits, if they're in the 5 times table, both numbers, if they're in the 5 times table, would end with either a 0 or a 5. Do they both go into the 2 times table? We know that this time, yes, they do, because both numbers end with an even digit. 412 divided by 2, and if you needed to write this down, you could, would be 206, and then 1,000 divided by 2 would be 500. Again, we would go through these questions. 10 times table, no. 5 times table, no. 2 times table, yes. And again, we could get to 203 250ths. We would then look through our questions again. 10 times table, no. 5 times table, no. 2 times table, no. Any other times table, no. So we would leave our answer. Once again, as I said with the first one, if you have any of these as your answers, you would get it correct. But I just want to make sure that some people are remembering to keep continuing to try and simplify fractions when we get the chance to, okay? The more you simplify, the more it stays in your mind and the easier simplifying is. So I want you to have a go at these 4 questions now, okay? So remember, you line them up. So this first question, I'll just get you started on the first one, 0.36. I can line it up here. And then have a look, we've got 36 hundredths, so how would we write that down? And then think, can we simplify at all? Then I've got number 2, number 3, and number 4, please. And I want you to pause the video now to give yourself a chance at answering those 3 questions. Okay, off you go. Right, you should have given yourself enough time to answer those 3 questions now, so let's have a look at the answers. So we should have seen that 0.36 is 36 hundredths. We should have seen that 0.9 is 9 tenths. And we should have seen that 0.503 is 503 thousandths. And that 0.45 is equal to 45 hundredths. Okay? Now let's see if we could simplify any of these fractions at all. So if you haven't simplified any of these yet, pause the video now and have a go at simplifying them. Okay, so you should have given yourself a chance to simplify those fractions. Let's have a look now. Now if we went through our 4 questions, we should have seen that 36 hundredths both are in the 2 times table, so we can get down to 18 fiftieths. Once again, they are both in the 2 times table, so we can get down to 9 25ths as our final answer. As I said before, any of these would be correct though. 0.9, we should have seen that they cannot simplify that at all. 0.503, you cannot simplify that at all. And 0.45 is 45 hundredths. We should have seen that both 45 and 100 are in the 5 times table, and therefore our final fraction would have been 9 20ths. Again, any of these that you can see on the screen here would be correct, so please mark your work. Last thing to look at then today before you go into a worksheet for yourselves is what if we have a number that's above 1? And this is where some people struggle a little bit because they think, oh my word, we can do it with it 0 point something, but as soon as the number gets above 1, it gets a little bit more tricky. Really, if we continue to use the same method that we've used all along, it is no trickier at all. So let's use our place value chart to help us out here. The first number we've got is 3.76. So remember where your decimal point goes, always between the 1s and the 10ths. And we've got 3 holes before the decimal point, and then we've got 0.76 after the decimal point. Now when we looked at our decimals before, we always had 0 ones. This time, look, we've got 3 ones. So I can write the 3 holes there straight away. Now, I've got 76 hundredths. So I can write 3 and 76 hundredths. So you can see that now I just have a mixed number. I have a whole number and a proper fraction together creating the mixed number. From here now, we could simplify our answer, couldn't we? So we could go through exactly the same. Now, just so that you are aware, if we are simplifying our answer, the whole number stays the same. We cannot simplify a whole number, it stays as 3 wholes. However, if we look at 76 hundredths, we can see they both go into the 2 times table, the numerator does and the denominator does, so we could then simplify our proper fraction. We could then simplify it again. Remember, when we are simplifying, the whole number does not get simplified. You cannot simplify 3 wholes, but again, they both go into the 2 times table, so we can simplify it again here. Let's look at number 2 then. Again, we're going to use a place value chart. Again, we have to remember where our decimal point goes. And again then we just line it up. We can see we have 24 holes before the decimal point, and then we have 905 or 0.905 after the decimal point. Again, before the decimal point tells us the number of holes we've got, so we've got 24 holes. And after the decimal point, now we can see it's really easy, we have 905 thousandths. So we've got 24 holes and 905 thousandths. And then finally, let's have a look at number 3, 781.6. Again, remember where your decimal point is. This time again, line up your digits correctly in the number, so I can see 781 holes before the decimal point, and I can see 0.6 after the decimal point. Again, before the decimal point tells us how many holes we've got, so we've got 781 on this occasion, and we have 6 tenths after the decimal point, so I can write 6 tenths here. Now, if you wanted to, you could simplify these two fractions, but if you just wanted to leave them the same, you would still get them right. So you make the choice when you are completing the work whether or not you want to try to simplify the proper fraction part of the mixed number, or you want to just keep it the same. Either way, you would still get the mark. So your turn now. So can you have a go at these 4 questions? Just like I did before, I will start you off on number 1, where we have got 24.88. We start with our decimal point. We have 24 wholes before the decimal point, and we have 0.88 after the decimal point. So you might want to think about how you can write that now as a mixed number. You might want to think about how you want to simplify that if you choose to simplify, and then have a go at number 2, 3 or 4. So please pause the video now to have a go at those 4 questions. So you should have answered all 4 questions now, so let's have a look at the answers. For number 1, we could have got 24 and 88 hundredths if we chose not to simplify it. If we chose to simplify it, we could have got 24 and 22 25ths. Both are correct. For number 2, we couldn't simplify the answer to number 2, but we should have got 9 and 713 thousandths. If I just show you that quickly here, we've got 9 before the decimal point. Remember where our decimal point goes. We've got 0.713. So we've got 9 wholes because we've got 9 ones, and then we've got 713 thousandths, which we can see here. Number 3, if you chose not to simplify, you would have got 305 and 8 tenths. If you chose to simplify, you should have got 305 and 4 fifths. And number 4, you have got 15 and 62 hundredths, or if you chose to simplify, 15 and 31 fiftieths. So please mark your work now. Now, the last thing you're going to do before you go into your worksheet is this. I want you to try to draw this table into your maths books, and I want you to fill in the missing fractions. Okay, now you can use any method that we've looked at, okay, today. You might want to label your place value columns. You might want to then simplify, but these are the decimals that you need to know off by heart by the end of year 6. You need to know the equivalent fraction to each of these decimals. Okay, so I want you to pause the video here and complete this table, please. And you should have now completed that. And you should have had 0.1 is equal to 1/10, 0.125 is equal to 1/8, 0.2 is equal to 1/5, 0.25 is equal to 1/4, 0.33 is equal to 1/3, and 0.5 is equal to 1/2. If you do not know these, copy them down now, and please, please, please try to learn them, because they are really important that you know these equivalencies. So pause the video now, make sure you have got them all correct, make sure you can learn them. So pause the video now. And you should have now completed copying that down. So now, you now need to log on to Class Dojo, and once again, you should all be used to this by now. There is a worksheet on there, okay, which has been set for today. It is all to do with converting decimals to fractions, okay. Remember, if you are struggling with this, me and Miss Beck are both live on Microsoft Teams from 10:30 until 11 o'clock to give you support with this work. Please log on to Teams at this time if you need this support. Again, some children did that last week and it really helped them. If you do not need that support, you do not need to log on. But please, if you are struggling at all, log on to that live Teams session from 10:30 until 11 so that you can go through this with either me or Miss Beck. Please remember to send pictures of all of your work. So the work in your maths books need to be sent over a message to myself or to Miss Chapman or to Miss Beck. And the worksheet, the activity that is on Class Dojo, needs to be sent across to your teacher as well, please. Okay, thanks for your work today, and I'll see you all tomorrow.